Hey there, and welcome to this explainer. Today, we're taking what looks like an intimidating quadratic equation and transforming it into a deeply logical, totally stress-free puzzle that anyone can solve. If you've ever felt bogged down by the trial and error of algebra, you are definitely in the right place. We're going to focus on the elegance of logic to break down one of the most powerful algebraic techniques out there, splitting the middle term. And we're going to do it step by single step, no rushing, just pure, satisfying mathematical structure. Here's our quick roadmap for today. We'll start with the quadratic puzzle, move right into the A times C method, hunt down our target numbers, actually split that middle term, and finally, use grouping to arrive at our solution. Let's get into it. Okay, section 1, the quadratic puzzle, confronting the equation. So here's the actual challenge we're tackling today. 2x squared plus x minus 300 equals 0. Now, if you're looking at this and cringing a bit, I totally get it. It looks intimidating right out of the gate. Why? Well, we've got this absolutely massive constant at the end, negative 300. And to make things even trickier, we have a leading coefficient of 2. It's not just your friendly, clean x squared. That 2 kind of changes the entire landscape of how we need to approach factoring. Which brings us to the million-dollar question, right? How on earth do we factor this without just blindly guessing? If you try to guess and check your way through all the possible factors of 300 while balancing that leading 2, you're going to be sitting at your desk all day long. It's incredibly frustrating. We don't want to rely on luck here. We need a foolproof detective-style method. To build that strategy, we really need to define our playing field. As you probably know, every quadratic equation fits into a standard form. ax squared plus bx plus c equals 0. So let's map our specific equation to this. Our a is 2, our b is a hidden positive 1, it's just sitting right there invisibly in front of the x, and our c is that giant negative 300. Keep these three players in the back of your mind, because they're about to do some heavy lifting. Moving on to section 2, the A times C method, finding the master key. Instead of just diving in and crossing our fingers, we are going to explicitly multiply our A and C terms together. Why are we doing this? Basically, we're merging the influence of that annoying leading coefficient and that massive constant into one single target. So step 1, we multiply A, which is 2, by C, which is negative 300. Then step 2 will be finding factors of that new product that add up perfectly to our B term, which remember is positive 1. So that gives us our crucial number, negative 600. This right here is our master target. We took 2 times negative 300, and now negative 600 is literally the mathematical lock we have to pick. Our entire focus right now shifts to this one integer. All right, section 3, hunting for target numbers, the logic of squares. We basically need 2 mystery numbers that multiply to negative 600, but add up to a positive 1. Now, whatever you do not start blindly listing out all the factors of 600. Let's use a bit of logic. Because our 2 mystery numbers must add to 1, they actually have to be consecutive numbers. Just let that sink in for a second. If 2 numbers multiply to a large negative, one's got to be positive and one's got to be negative, right? And if they add up to exactly positive 1, their absolute values are just 1 digit apart. They are sitting right next to each other on the number line. Think about it. 5 and negative 4 add to 1. 10 and negative 9 add to 1. We just need consecutive numbers that multiply to something around 600. And here is where we unlock a pretty brilliant shortcut. If we're looking for 2 consecutive numbers that multiply to roughly 600, they are essentially going to be the same number squared. So let's just look at perfect squares near 600. 24 squared is 576. 25 squared is 625. Boom! Our target of 600 is trapped right between those 2 perfect squares. This tells us immediately that our suspect numbers must be exactly 24 and 25. No guessing, no massive list of factors. Just pure logic taking us right to the answer. Okay, so we know it's 24 and 25, now we just gotta figure out the signs. Let's test the options. Side A gives us negative 25 and positive 24. But wait, if you add those, you get negative 1. That's a no-go because our B term is a positive 1. Now look at side B, positive 25 and negative 24. Add those together, positive 1. So side B is absolutely our winner. Positive 25 and negative 24 perfectly multiply to negative 600, and they add up to the positive 1 we need. The hunt is officially over. Which brings us to section 4, splitting the middle term, the reveal. We've cracked the code on those target numbers, so let's plug them back into our equation and see what happens. And here is the namesake of this whole method. We take that single tricky x from the middle of our original equation, and we literally split it into negative 24x and positive 25x. Now, the actual value of the equation hasn't changed one bit. Negative 24x plus 25x is still just 1x. But check out how we arrange this. We strategically parked the negative 24x right next to our leading 2x squared. Why do that? Well, 24 and 2 are both even. They share common factors. This little bit of planning is going to make our final step incredibly smooth. All right, section 5, grouping to the solution, the final steps. This is where all that careful prep work is going to pay off big time. First things first, we take our four terms and cleanly group them into pairs. We just throw parentheses around the first two terms, so 2x squared minus 24x, and we do the exact same thing for the last two terms, 25x minus 300. We've just taken this big problem and broken it into two bite-sized, totally manageable pieces. Next, we find the greatest common factor for each specific group. In that first group, 2x squared minus 24x, we can easily pull out a 2x. That leaves us with x minus 12 inside the parentheses. Now for the second group, 25x minus 300. Let's factor out a positive 25, and look at what's left behind. 300 divided by 25 is exactly 12, leaving us with another x minus 12. Do you see how that matching binomial perfectly reveals itself in both groups? That right there is the mathematical proof that our logic was flawless. If those parentheses didn't match, we'd know we messed up somewhere, but they do. For our grand finale, we just pull out that common, shared x minus 12 binomial right to the front. What's left over? Well, the 2x from the first group and the positive 25 from the second group. We just package those together into their own set of parentheses. And there it is. We arrive at our beautifully factored form, 2x plus 25 times x minus 12 equals 0. We literally took a monster of a quadratic, bypassed all the endless guessing, relied strictly on pure logic, and completely solved the case. Now that you've seen firsthand just how methodical, structured, and honestly painless splitting the middle term can be, I want to leave you with this thought. Math is really just a series of puzzles, waiting for the right strategy. So what other mathematical mysteries, or maybe even life's complex problems, are you ready to confidently decode by just breaking them down one logical step at a time? Thanks so much for exploring this with me today, and as always, keep looking for the logic hidden in the numbers.